You have seen this cloud, a tall pillar of pink and blue gas, glowing in the dark. It hangs on classroom walls, phone screens, the covers of books, the Orion Nebula, the most famous cloud in the sky. And you have probably never been told what it actually is. It is a nursery where new stars are being switched on right now. But it is only one kind. Across the universe, there are 11 kinds of clouds, some building stars, some marking where stars die, and one that is the single coldest place ever found, colder than empty space itself. In 9 minutes, you will know everyone. Start where stars are born. An emission nebula is a cloud that makes its own light. It is a vast region of hydrogen gas, and buried inside it are young, ferociously hot stars. Those stars flood the gas with ultraviolet radiation, and the gas answers by glowing the same way the gas inside a neon sign glows when you run current through it. That is what you're seeing in the Orion Nebula, not reflected light. Light, the cloud is producing itself, and Orion is close enough to prove it. 1,500 light years away, wide enough that if your eye could gather more light, it would spread across your night sky wider than the full moon. Inside it, more than 1,000 stars are forming at once. Everything you find beautiful about that photograph, the color, the glow, the structure, is the visible signature of stars being born. The pink is hydrogen. The specific shade has a specific cause, a hydrogen atom hit by starlight, releasing one exact wavelength of red. You are not looking at a painting, you are looking at physics, lit from the inside. But some clouds make no light of their own at all. They only borrow it. A reflection nebula does not glow. It shines the way dust in a sunbeam shines, or fog around a streetlight. The gas and dust are simply too far from any star to be lit into emission. So instead, the cloud scatters the light of nearby stars back to you. And here is the detail almost no one notices. Reflection nebulae are almost always blue. Not by accident. It is the same physics that makes Earth's sky blue. Fine dust scatters blue light far more easily than red. Look up at a clear afternoon, and you're watching a planet-sized reflection nebula overhead. The most famous example sits around the Pleiades, a little cluster of stars many people have seen without knowing its name. Around those bright blue stars hangs a faint blue haze, starlight caught in a passing dust cloud. For a long time, astronomers thought the cloud was the leftover of the star's birth. It is not. The Pleiades are simply drifting through an unrelated cloud, lighting it up as they pass, like headlights sweeping through fog. Two clouds side by side, one glowing, one only reflecting. The third kind does neither. A dark nebula produces no light and reflects none. It is a cloud so dense, so packed with cold dust that light cannot get through it at all. So you do not see the cloud. You see the hole it makes, a patch of sky where the stars simply stop. The most famous is the Horsehead Nebula, a dark column shaped unmistakably like a chess knight standing black against a glowing red background. You are not seeing the horsehead. You are seeing everything behind it blocked out in the exact shape of the cloud. Think about how strange that is. It is the one object in the sky you see only because of what it hides. And these dark clouds are not empty. They are the opposite. They are the coldest, densest, most crowded gas in the galaxy. And that is exactly why they matter. It is inside dark nebulae that gravity finally wins, pulls the gas together, and lights a new star. The darkest clouds in the universe are where the next stars are being made. In total blacks, invisible until the moment they ignite. Which brings us to the place where that ignition happens on a scale almost too large to describe. When a dark cloud finally collapses and its first stars catch fire, it becomes something astronomers call an H2 region, a full star nursery, lit from within. This is the emission nebula at its most productive. Not a single cloud with a few young stars, but a stellar factory turning out hundreds of them at once. And it produces the single most famous image in all of astronomy. Inside the Eagle Nebula stand three towering columns of gas, the pillars of creation. Each pillar is not miles high, not planet high. The tallest is around 4 light years tall, the distance from our sun to the next star over. Newborn stars are forming inside their tips right now. And here's the part that stops people. When Hubble and later Webb photographed those pillars, they photographed light that left them thousands of years ago. Some astronomers suspect the pillars have already been destroyed by a nearby supernova. That we're looking at a monument that may no longer exist, still glowing in our sky because its light is still arriving. Those are the clouds that build stars. But a cloud can also mark the exact place a star has died. The first death cloud has the most misleading name in astronomy, a planetary nebula. It has nothing to do with planets. When William Herschel found these round, glowing objects in the 1780s, they looked like faint planets in his telescope, so the wrong name stuck for centuries. What they actually are, a dying sun-like star, gently shedding its outer layers into a glowing shell. The Ring Nebula is the classic, a smoke ring puffed off a dying star, lit from the white-hot core behind it. This is not violence. It is a star exhaling, and it is exactly how our sun will end. Hold that. We return to it. This one is violence. When a star star far larger than the sun dies, it does not exhale, it detonates, the most powerful explosion in the universe. What it leaves behind is a supernova remnant, a shockwave of shredded star, still tearing outward. The Crab Nebula is the most studied. In 1054, Chinese astronomers recorded a new star so bright it showed in daylight for 3 weeks. That was the explosion. What we see now in that spot is the wreckage, still expanding at nearly 1,000 miles a second, almost 1,000 years later. The shape of that death, though, is stranger than a simple shell. Many dying stars do not blow an even sphere. They blow 2 lobes, a mirror image hourglass, wide at the waist, flaring at both ends. Astronomers call them bipolar nebulae, and how a round star makes such a precise butterfly shape is still not understood. The leading idea, a disk of dense material around the star's equator, pinches the outflow, forcing gas out only through the poles. The result looks engineered. Perfect twin lobes, glowing, symmetrical, spanning light years, sculpted by a star in the act of dying. And one bipolar nebula does something no other object can. It gets colder than space. The Boomerang Nebula, sitting 5,000 light years from Earth, is the coldest known place in existence, 1 degree above absolute zero, colder than the deepest space between galaxies, colder even than the faint afterglow of the Big Bang that warms the rest of the universe. It is the only natural object ever found colder than that afterglow. The cause, a dying star, flinging gas out so fast the cloud expands and chills, like air from a can, a refrigerator running on death, and its shape is a lie. It looks like a boomerang, only because dust hides its true hourglass. The next cloud is caught mid-change. Between a star shedding its layers and a finished planetary nebula, there is a brief in-between stage, a protoplanetary nebula, a cloud caught in transformation, gas expelled, but not yet lit up by the exposed core. It lasts only a few thousand years, a blink in a star's life. The boomerang is one. We are watching a nebula become a nebula in real time, but the strangest death clouds come from the strangest stars. Some stars are so massive and violent, they strip themselves apart before they even explode. These are Wolf-Rayet stars, dozens of times heavier than the sun, burning fuel so fast they blast their own outer layers off in a furious wind. That wind carves a glowing bubble around the star. A Wolf-Rayet nebula, one around a star named WR124, was among the first things Webb photographed. A dying giant wrapped in the glowing shroud of its own shed mass, thrown off in the few thousand years before it dies for good. The death clouds of the rarest, heaviest stars come back to the planetary nebula, the gentle one. The sun's ending. In about 5 billion years, our sun will run out of fuel, swell, and shed its outer layers into that same kind of glowing shell. From a distance, it will look like the Ring Nebula, beautiful, silent. And here is what that shell is made of. Every atom the sun casts off, the carbon, the oxygen, the nitrogen, it forged over billions of years, drifts out into space, and that enriched gas becomes the raw material for the next stars, the next planets. And yet, the carbon in your body, the oxygen in every breath you take, all of it was made inside a star and scattered by a nebula exactly like the one the sun will become. You are built from an earlier star's ending. Every cloud so far lives in our galaxy, but nebula are everywhere. The Tarantula Nebula, the most violent star-forming region known, sits in another galaxy, the Large Magellanic Cloud, 160,000 light years from us, and still outshines every nursery in the Milky Way. Some nebulae stretch across distances so vast they hold enough gas to build millions of suns. Wherever there are galaxies, there are these clouds, being born, glowing, dying, seeding the next ones. The same story in every corner of the universe, which leaves one last type, and you already know it because you are made of it. 11 types of nebula. Clouds where stars ignite, clouds where stars die, clouds colder than space, and clouds shaped like hourglasses no one can fully explain. But the last one is not out there. It is you. Every atom in your body heavier than hydrogen, the iron in your blood, the calcium in your bones, the oxygen you are breathing right now was forged inside a star and scattered by a nebula billions of years before the Earth formed. You are the part of one of these clouds that woke up and looked back at the sky. The next time you see that photo of Orion, you are not looking at something far away. You are looking at where you came from. Subscribe. Next, every type of neutron star.